Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 maths, continuity and differentiability part 3. We request you to subscribe, like and share our channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's lesson. Today we'll see example number 10. So, example number 10, it is given that discuss the continuity of the function of f defined by fx is equal to x plus 3 if x is less than equal to 1, x minus 3 if x is greater than 1. So, the function fx is defined at all the points of real line. Real line. Therefore, we we may have three cases. Case 1 is let to save the time and to make the video short, we have drawn the first we have drawn the picture, then we'll explain you what is the picture. So the diagram. So first thing, if we draw the line x is equal to x minus 3, we'll get something like this. And if you draw the line x is y is equal to x plus 3, then you will get this line. Now let us see the question. Now let us see the rest of the part of the solution. So in the case 1, let x is equal to c be any arbitrary real number. So in case 1, let x is equal to c be any arbitrary real number in the domain of fx. C is equal to so if c is less than 1, then fc is equal to c plus 3. Therefore, limit x tends to 0, fx is equal to limit x tends to 0, x plus 3 is equal to c plus 3. Thus, f is continuous at all real number less than 1. So it is pretty simple. So let us see. So there are three cases. Let us see the other two cases. So case 2 is if CE is less than if C is greater than 1, then FC is equal to C minus 3. Therefore, therefore limit x tends to 0 limit x tends to c, fx is equal to limit x tends to c x minus 3 is equal to c minus 3 is equal to fc. Thus fx is continuous at all points x is greater than 1. Now comes case 3. So in case 3, if c is equal to 1, then left hand limit of fx of fx at x is equal to 1 is limit x tends to 1 minus fx is equal to limit x tends to 1 minus x plus 3, which is equal to 1 plus 3 is equal to 4. The right hand limit of fx at x is equal to c is limit x tends to 1 plus fx is equal to limit x tends to 1 plus x minus 3 is equal to 1 minus 3 is equal to minus 2. Since the left hand and right hand limits of fx at x is equal to 1 do not coincide. So left hand limit and right hand limit do not coincide. Therefore fx is not do not coincides at x is equal to 1. Therefore, fx is not continuous at x is equal to 1. So the graph is shown. So x is equal to 1 is the only one point which is discontinuous of fx and which is shown in the graph. So you can see in the graph that this left hand and right hand limit do not coincides at x is equal to 1. So this is the graph. Let us move to the next sum, example number 11. Now let us see theorems related to continuity. So we can write theorem. So let f and g be continuous at x x is equal to c and c is the element of a b for some interval a b. Then f plus g is continuous at x is equal to c. Then this is the first theorem. Second theorem is kf is continuous at x is equal to c k is the element of R. Third, f minus g is continuous at x is equal to c. Fourth is f multiplied by g is continuous at x is equal to c. Fifth one is k upon g is continuous at x is equal to c if gc is not equal to 0 and k, where k is the element of a real number. So sixth, f upon g is continuous at x is equal to c if gc is not equal to 0. So these are the 6 theorems which you should remember. Let us do few examples related to this. So first example is proof sine modulus x is continuous on R. So let us see the solution. F R tends to R, fx is equal to mod x and g tends to R gx is equal to sin x are continuous. Therefore, GOF R tends to R, GOF X is equal to GFX is equal to G modulus of X is equal to sine modulus of X is continuous for all X element of R. Let us see one more example. Proof function R tends to R, fx is equal to modulus of 1 minus x plus modulus x is continuous. So let us see the solution. Gx is equal to 1 minus x and hx is equal to modulus of x are continuous. on R. Therefore, gx plus hx is equal to 1 minus x plus modulus of x is continuous. Therefore, fx is equal to ho g plus h x is equal to h g plus h x is equal to 1 minus x plus modulus of x is continuous as h and g are continuous on R. So let us see the next question. Fx is equal to k cos x upon pi minus 2x, where x is not equal to pi by 2, and k square where x is equal to pi by 2. Can you find k so that f is continuous at x is equal to pi by 2? So we have to find the value of k. Let us see the solution. Limit x tends to pi by 2, fx is equal to limit x tends to pi by 2 k cos x upon 2 pi by 2 minus x is equal to limit alpha tends to 0 k sin alpha upon 2 alpha is equal to k by 2. Here we have considered one thing. Let alpha is equal to pi by 2 minus x. So f pi by 2 is equal to k square. Since f is continuous, it is given in the question, at x is equal to pi by 2, limit x tends to pi by 2, fx is equal to f pi by 2. Therefore, k by 2 is equal to k square. Therefore, k is equal to half or 0. So, this is the solution. So, example number 4. It is given that fx is equal to sine 4x upon 9 where x is not equal to 0 and k square where x is equal to 0. Find k if f is continuous for x is equal to 0. So, first we can write limit x tends to 0 fx is equal to limit x tends to 0 sine 4x upon 9x. Therefore, we can write limit x tends to 0 sine 4x upon 4x. Four upon 9, which is equal to 4 upon 9. Therefore, f0 is equal to k square. K square is equal to 4 by 9 for f to be continuous at x is equal to 0. Therefore, k is equal to plus by 2 plus minus 2 by 3 for f to be continuous at x is equal to 0. And this is the end of continuity. This is the end of continuity. Differentiability we'll see in the next class. Before we end, we request you to subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our videos and supporting us. Thank you.